Hello and welcome to a new video. As you can see, it's beginning to look a lot like Christmas, so the holiday season is coming. You can see here we have a Bobo and this snowman here. Isn't it cute? Look at that. Then we have this Bobo, beautiful, and here we have another cute snowman. Look at his cute face, amazing. And here we have another one. Look at that. Such a beautiful thing. Such a joy to look at this stuff. But this video is actually about this thing here. This video monitor here. And I will turn on the light so that you can see it better. So there we go. And this monitor here, this video monitor, is actually a Commodore video monitor. It's the Commodore 1084S video monitor, and this monitor can be used for all computers like the Commodore 64 and Amiga 500 and such devices. And since this is a video monitor, you can also connect your DVD player or VCR or any other thing, satellite receiver or any other thing which has a video output, and you can use it as a monitor. And the cool thing about this thing is it has also built-in stereo loudspeakers, so you can also hear audio from your computer or your video device. And yeah, I want to use this monitor in the Christmas holidays to play some classic games with my Amiga 500. And yeah, this monitor is unfortunately broken. It's not working. Yeah, so this video is gonna be a repair video in which we will try to fix it and repair it. First of all, I will show you what's wrong so that you get a picture of what we have here. So for that I have to connect first power cord. I always use my isolation transformer for this repair, so I have to turn it on. And now I've connected the monitor to my isolation transformer, and yeah, now I will turn it on to show you what it does. So listen carefully because it makes an interesting sound. So as you can hear, hopefully you can hear it, hopefully the microphone picks this up, it makes this high-pitch squeaking noise. And it creates no high voltage on the CRT and nothing else, just this noise. Also the power LED is still off, it's still dark, and if I connect the video signal it doesn't change. So this is the failure. And if I turn it off again, now listen carefully, listen carefully. It makes this interesting sound in which the intensity, or I think also the frequency of this high pitch sound decreases. So I will show it you again. So I turn it on. You can hear the high pitch noise, and now I turn it off, and you will hear it decreasing. So hopefully this came through the microphone. Yeah, and this is the failure of it. And I already looked it up on the internet, and I've also looked into the service manual of the thing, and I'm pretty sure what's wrong with it. I think it's the Flyback Transformer, and the Flyback Transformer is the transformer which is used in CRTs, CRT monitors and television and such, to create the high voltage which the CRT needs to operate. It creates different high voltages, and I think this is the broken part in this monitor. But yeah, we will disassemble it to find that out together. So let's do that. So to open it, the only thing that we have to do is to unscrew these 4 screws right here, plus this one extra screw on the back. This is important that you don't miss this screw, because you cannot take the cover off if you don't do it. I've opened it up before, so I know that. And so I will start doing that. And afterwards we'll be able to get up of the cover of the motor and see what's actually inside. The cover slides off like this, and one important thing to note is that the loudspeakers, the stereo loudspeakers inside of this monitor are connected with the cover via this cable. So I have to unplug them to remove the cover. As you can see here, I have to unplug this and this. So these two plugs need to be unplugged to get the cover opened. As you can see, if you pan around, here you can see this is one of the loudspeakers, the other loudspeakers on the other side, and here we go. Here we have this plug and the other one. So here we have the candidate. This is the Flyback Transformer, which I think is broken. So I will start to probe around a bit on this guy and see what I find, and then I will be right back and share my findings with you. So I'm back. As mentioned before, I think the problem is caused by the Flyback Transformer. So I will start probing there. So I will start probing the pins of the Flyback Transformer with the oscilloscope to see the signals on here. But before we do that, first of all, it's extremely dangerous to probe on such equipment because it contains very high voltage. Don't do it if you don't know what you're doing. It's very, very important. Yeah, and before I start probing on it, I will show you the service manual, which shows you how the the Flyback Transformer is connected and how it is constructed. And here we have the Flyback Transformer. It's this long thing here, and here we have the primary side, and here we have the secondary side of the Flyback Transformer. And I will start probing on the primary side. And the most interesting thing for me, first of all, is this winding right here, which has pin number 3 and 5. And on pin number 3, we have the supply voltage for the Flyback Transformer, which is here we have 128 volts. It's extremely hard to read. And on pin number 5, we have the switching transistor, which is there to switch the Flyback Transformer. So it switches on and off at a very high rate, so that it creates the AC voltage to drive the Flyback Transformer. Yeah, and I will start to hook up my oscilloscope on pin number 3, and let's see what we get. I would expect a high voltage, which is about, so we have 228 volts here, so it's a bit less on this side, but I will expect in this a voltage within this range, so near at 128. Yeah, so let's look at the oscilloscope. So first of all, here you can see my oscilloscope probe on pin number 3 of the Flyback Transformer, and the oscilloscope ground is on the ground of my of the monitor. And here you can see the oscilloscope. I will zoom in a bit so that you can see it better. So there we go. I've set it to 50 volts per division, which means that we have 100 volts at 2 divisions right here, 150 here, so it should be about here in this range if it's working fine. And I will turn it on right now with the isolation transformer. So look at the oscilloscope screen, and as you can see, it's extremely low, so much less than expected. So we'll zoom in a bit for you. By the way, here I'm using my repaired TDS 460 oscilloscope, so if you are interested, I have a series of videos in which I will show you how to repair this oscilloscope. Yeah, but back to the monitor. Here I will trigger it a bit more, set it to 50%. So as you can see, it's way too low. It's now we have 2 volts per division, so which means we have 2 volts right here, and the lower side of this ripple, the lower ripple voltage is about 3 volt, and the higher ripple voltage. The upper ripple voltage is not lower than 4 volts. So this is way too low. So this is clearly not working as it should. So you can see it a bit clearer. So the lower side is below 3 volt actually, and the higher side is 3.5 volts. So way too low. And so I think something inside this flyback transformer must be shorted to cause this problem. So I will turn it off right now so you can see what happens when we turn it off. As you can see, the frequency decreases when it shuts down, and then after a while it goes completely flat. So I will start to probe around with my multimeter to see if I can find any short on here. Yeah, so let's do that. After probing around a bit with my multimeter, I found that pin number 3 is shorted to pin number 10 of the flyback transformer, and I think this is causing the problem. And what I also found is that pin number 10 has a pretty low DC resistance to pin number 9. It's actually about 0.5 ohms. I cannot really measure it accurately because my multimeter does not measure really low resistance values. But since pin number 10 has a very low DC resistance to pin number 9, and pin number 9 is ground, so now if pin number 3 is shorted to pin number 10, and 10 has a low resistance to 9, this could cause now that the primary voltage or the 128 volts drops this low because of the short from pin number 3 to 9, because of the short from pin number 3 to 10, and pin 10 to 9 has a pretty low resistance. Yeah, so this means that this flyback transformer is definitely broken, and I have to replace it. I've already ordered a replacement for the flyback transformer, which you can see here, which is this one. This is the replacement. You can order it too. It's HR 7533, and this should fit. I will show you. I will open it up for you. So here you can see it very well packaged. So there we go. This is the replacement flyback transformer, and so I will have to desolder it and replace the flyback transformer. So let's do that. Before we can unsolder the flyback transformer, we have to do another very important thing, which is to discharge the CRT, because it can hold dangerous voltages even if the monitor is off for a longer period of time. In this particular case, this monitor went bad a long time ago, so there is no high voltage on this CRT, and since the flyback transformer isn't doing its flyback transformer thing, there is clearly no high voltage on this CRT. But I will show you how to discharge it anyway, because it is important if you do such a repair to always discharge it first to make sure that there's no high voltage left on the CRT, no dangerous high voltage. Discharging it is actually pretty simple. For that, you just need a crocodile clip wire like this, and I will clip this crocodile clip to ground. Make sure that it is actually a ground point. I use this heatsink here because I already measured it. It is actually ground. Don't connect it just on a metal piece anywhere inside this, because you cannot be sure that it is ground. Connect it somewhere where you know that it is ground, where I've measured it or looked it up at the schematic. And on the other side, I have this clip. I connect the screwdriver. So here I have a screwdriver. It's actually a flathead screwdriver. This is the best for this. And I will connect this crocodile clip on the screwdriver. It's hard to connect because it's not a very good crocodile clip, and basically it's a bit too small for this. But here we have it connected. And now what I do next is to go under this anode thing of the flyback transformer, and then one thing is very important, that you touch the contacts inside. So don't just go a bit, you have to be really sure that you touch the contacts, and that way you can discharge it, the anode, and with the help of your other hand you can then remove it. So there we go. Here we have removed it now. Here you can see the connection, and here we have disconnected it. So this was the first thing that we have to disconnect, and we have already discharged it. And now the second thing is just the connector of the CRT. So just unplug it like this, and as you can see there are two connections which goes right into here, so we have to desolder them so that we can replace the flyback transformer. And now comes the hard part, because I have to desolder the flyback transformer, and it has lots of connections on its bottom side, so it's it's hard to desolder, but I will do that right now, and I will be back when I'm finished with this desoldering job. So here I'm back. Now I have replaced the flyback transformer. Here you can see the old one and some important notes. So first of all, you have to solder in the flyback transformer, of course. Then second one here, this anode clip goes onto the picture tube, like I showed you before, I disconnected it before, so you have seen it, where it was. And then we have these two extra connections. This one is for the focus, so this is the focus voltage, which is the black and thicker wire, and the thinner wire is the screen voltage. And basically on the new flyback transformer they are both red, but they are similar connected like on the old one. So the focus wire comes out of the top of the flyback transformer, and the screen wire is here connected on the bottom of the flyback transformer, so you can find it on the new one. And yeah, the focus is this thicker cable now, red, goes right here, and the screen also goes where it was. So I've reconnected it, and when you turn this thing on the first time, you will find that there's no picture at all. But don't worry, this is normal, because the screen voltage is turned to 0 if you have a new flyback transformer. You have to turn it clockwise to increase the brightness, and so that you can see something. And secondly, the focus is also not right. So if you turn on the screen and you start seeing something, then it's not sharp. Then you have to adjust the focus to get it sharp again. And for example, if you have a test pattern generator, which is quite useful for such a task, you can adjust this thing easily. And I already did that. I already adjusted it with my test pattern generator. And now I show you how it works. For that, I will move it a bit so you can see the screen a bit better. And now I will turn it on. I've connected it still to my isolation transformer, and I will turn on the isolation transformer. And now you can see it's starting up, and you can hear it as well. And yeah, as you can see now, it is working just fine. You can see here all the colors are there. I've also adjusted the focus so we have a sharp picture. And yeah, now it's working fine again, as it should. So this concludes our Christmas Commodore monitor fixing video. So now I can play my Amiga 500 games again, which is great. And I have a great monitor for that. So yeah, this concludes my video, and I can say thanks for watching and have a happy Christmas time. Bye.